Okay, here's another interesting application of arc length, which we know is easy to calculate with radians. So it says if a central angle is very small, there's little difference in length between an arc and the inscribed chord. So what they're saying is if this angle is very small here, then you can imagine that the arc intercepted by that angle and the straight line distance from the two radiuses, the lengths of those approach each other as the angle gets very small. You know, maybe you're a far distance away from something, you know how far you are from it, and you can use one of those survey angle measurement devices to get the angle between the two ends. You know, this is theta. You know how far you are from it, and so the arc length is close to the actual straight length of the object, right? So they're approximately equal. The arc length is approximately equal to the length of the object. Okay, so a railroad track in the desert is 3.5 kilometers away. A train on the track subtends horizontally an angle of 3 degrees 20 minutes. Find the length of the train. So the train is on a track, you know, straight across, and from 3 kilometers away, that the train makes an angle of 3 degrees 20 minutes. So approximate the length of the train. Well, we can approximate it by getting this arc length, the arc length that subtends this angle. So what is this angle as a decimal? Well, 20 minutes is how many degrees? There's 60 minutes per degree, so that's 1/3 of a degree. So 3 1/3 degrees is 3 times 3 is 9, so that's 10/3 of a degree. Okay, how many, let's convert that to radians. How many radians is 10/3 of a degree? So 180 degrees for every pi radians. So that's 10/3 times pi over 180. It's pi over 54. Okay, so this is 3.5 kilometers, this radius. So what arc length does a circle with radius 3.5 kilometers and then with angle that intercepts the arc, pi over 54 radians, what arc length is that? So S is equal to theta r. So S is equal to pi over 54 times 3.5. So the train is approximately, so pi times 3.5, about 0.2 kilometers long. Okay, same problem, but now the railroad track is 2.7 miles away, and the train subtends an angle of 2 degrees 30 minutes. Okay, so now we're in miles, but I mean, that's fine. What's this angle in radians? So 30 minutes is 1/2 of a degree, so 2.5 degrees. That's 5/2 degrees. What is that in radians? So 5/2 times pi over 180. 5 divided by 180 is 36. So pi over 72 radians. So S is equal to theta r. Pi over 72 times 2.7 miles. About 0.12 miles.